There are two ways to describe a rational expression and what it means. The way we're going to start with today is a rational is whenever you have a polynomial and you divide it by another polynomial. And this can be equal to, it can be equal to y, it could be equal to f of x. So a polynomial divided by a polynomial is going to be equal to your output. And these are going to be your inputs. That's the abstract way of looking at rational expressions. So a rational number could be like 5/9. A rational expression, a rational function would be like f of x equals 5/9x. The main idea for a rational function is that in the function, the x is in the denominator. So you have y equals 1/x. This is the parent rational function. And you've actually seen these before earlier in the class. Whenever we were talking about polynomials, part of that was, well, even here, whenever we're doing powers at the start of the third 9 weeks, you can see that we have a polynomial in the numerator and in the denominator. We did polynomials divided by polynomials. So we did the math before, and whenever we did these, we used long division. Today, I'm going to try to show you how to do it without long division, the shorter way. This is a rational function. And so is that, and so is that, and that. All of these are rational functions, as long as it's a polynomial divided by a polynomial. Okay, so the requirement, a polynomial divided by polynomial, and the denominator cannot be 0. And what that means is whenever you have your polynomial divided by polynomial, when you have your g of x equals 1 divided by something, you can't have 1 divided by 0, and you can't have 1/x, and then you can't do h of 0, 1/0. Whenever you're doing this, whenever you're plugging in things into these rational expressions, you have to be careful about what you're plugging in, because we, in this class, don't divide by 0. It would give you something that's undefined. And this would also be undefined. We don't know, we can't be precise in saying what 1 divided by 0 is. We can't determine if it's positive infinity or negative infinity. And even if it was infinity, you can't actually be infinity. You would get close to it, but you can't be that. You would approach it. You can get close to it, but that's it. So we say that this number, 1 divided by 0, is undefined. In this function, it is, at least. But there are other times, so just because the denominator can't be 0 doesn't mean we can't plug in 0. For example, we can plug in 0. We can plug in x equals 0, but if we do that, the denominator can't reduce to 0. If we plug in x equals 0, the denominator can't reduce to 0, or else the function is going to be undefined right there. So let's just go ahead and do an example of, the point of today's lesson is to simplify them, so let's simplify. Example 1, 6x plus 12 divided by x plus 2. We're going to simplify. So if we're going to simplify, that means we're going to reduce. So let's factor out a common denominator, x plus, we're going to factor out the 6. We get x plus 2 over x plus 2. Now that we see that there is the same exact thing in the top and the bottom. And it's not just that it's the same thing, but it's that we are multiplying. So this would be equal to 6 times x plus 2 over x plus 2. I think we've used this fact before, but I don't think I've ever drawn it out and shown that it's because this 6 is multiplying. It doesn't have to multiply on the top. It can multiply off to the side. We can have 6 times x plus 2 over x plus 2, and these two things are going to reduce. They're going to be, well, x plus 2 fits into x plus 2 exactly one time. So it's 6 times 1, and which means it's just the number 6. So back here, once we have 6 times something, and we're dividing by that same something, then we can do this and just say the answer is 6. We could have gotten the answer was 6 back there. Example 2. 12c squared over 3c plus 6. So we see that we have something squared in the top and nothing squared in the bottom. And we have two things in the bottom, so that means we're probably not going to cancel out any of the variables because we only have one thing on top but two things in the bottom. But if we factor out the bottom, if we get a common factor, we can pull out a 3 and get c plus 2 on the bottom. And then from this 3 can reduce with the 12. We can do 12 over 3 times c squared over c plus 2. And then this 12 over 3 can become the number 4. Oh, put too many equals. 4c squared over c plus 2. And this 4 is multiplying the c. Here's one that's more on this new level, because those first examples were, if we had never done what we did 6 weeks ago, 9 weeks ago, then that would have been where I would have left today's lesson. But now we've dealt with polynomials, we've dealt with the weird ones, we've factored them for weeks, we graphed them for weeks. Well, some of us did, some of us didn't. Some of us just hid in our rooms and did nothing for math. And then let's factor this bottom. If I need a plus 6 but a minus 7, then I'm going to have to do two negative numbers, a minus 6 and an x minus 1. We needed to factor the bottom so that way we could reduce it. We needed to factor the bottom so that we could reduce the function to its simplest form. Now that we see we have an x minus 6 on top and the bottom, these two are going to become the number 1. I'll show that step one last time. So we're just going to rearrange. So the 2 I'm going to keep on the left, and I'm going to move the x minus 1 to the left, and both of these numbers are going to multiply x minus 6 over x minus 6. I just rearrange things because whenever we're multiplying fractions, we're allowed to rearrange and multiply, divide in any order we want in PEMDAS. So these two are going to become the number 1. So this is 2 over x minus 1 times 1. We don't care about times 1 because it doesn't do anything. So it's just 2 over x minus 1. That's the function. Later this week, you're going to graph that. Maybe next week, in the last week of school, you'll graph that. Or if you're watching this in some other future time, then next week won't be the last day of school. The why we reduce it to the simplest form is so that we can take into account this. Because we want to know, do I get to plug in 0 or can I not plug in 0? And the easiest way to know what you can and can't plug in is if you're in the simplest form, then here in 2 over x minus 1, it's really easy to find out that the x that I cannot plug in, what I can't have, we can't have 0 on the bottom. We don't want that. So if we were going to make a graph of this, then we would not want x minus 1 equal to 0, which means we do not want x to be equal to 1. If we graphed that, this would be undefined. And that's something, let me think. Let me see if we actually need to talk about that in this lesson. No, in this lesson we don't need to talk about that. We'll talk about that in the next lesson. So for this one, the main thing you need to do is step 4, if you'll ask them. My favorite thing in math is taking something ugly and turning it into something neat. Example 5. This is the more complicated type of simplifying. 5x minus 15, 9 minus x squared. And if we factor out the 5 on the top, 5, x minus 3, 9 minus x squared, we can see that the 9 minus x squared looks a lot like whenever we have x squared minus 9, and this one would factor to be x plus 3, x minus 3. But it's not the 9 that's negative. We don't have the 9 negative. We have the x negative. So all that means is that whenever we factor this, 9 minus x squared, it's going to be the 3 that goes first. The factor of the 9 goes first, and then we can have a plus x, and then we're going to have a 3 minus x. And if we multiply this back out, we will get 9 minus 3x plus 3x minus x squared, and these two cancel out. So that means we did it right. So then let's write this simplified form. 5x minus 3, 3 plus x, 3 minus x, and then we see that I have an x minus 3 on top. I have an x plus 3 on the bottom. That doesn't work. I have a negative x plus 3 on the bottom. So we're going to have to change one more thing. 5x minus 3. And then let's make this so that the x is first for the first factor. And then for the second factor, we're going to pull out a negative number. We're going to change the signs. We're going to change the signs of both of these. If we change the signs of both things inside of the parentheses, of everything inside the parentheses, because sometimes we'll have more than two things. If we change the sign of everything in that parentheses, that would be a plus x and a minus 3. And if we took a negative out of both of those, we put it out in front. So now we have an x minus 3 and an x minus 3 that we can reduce out. And we have 5 over negative x plus 3. If you wanted to, you could put the negative up there. As long as you put the negative somewhere and it's multiplying the first thing of either the top or the bottom, that's fine.